Hello, Algebra 2 students. Today we will start our unit on probability. We will be doing 10.1 notes, apply the counting principle and permutations. A sporting goods store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? Here's how you would go about doing it. You draw a tree diagram. The 3 blanks on the farthest left should be the 3 types of snowboards. So you have all mountain, freestyle, and carving. If you choose all mountain snowboards, you can get soft boots, or you can have your choice of hybrid. Same with the other types of snowboards. And so you can have all mountain soft, all mountain hybrid, freestyle soft, freestyle hybrid, carving soft, carving hybrid. That's a total of, here's one option, 2, 3, 4, 5, 6. So you have 6 options altogether. What did I do? I took the 3 types of snowboard and multiplied it by the 2 types of boots, and that gives me 6. Applebee's is running a special You Pick 3 meal deal. You have your choice of one of 3 appetizers, so mozzarella sticks, chicken fingers, or chips and salsa, 4 entrees, pasta, chicken, beef, or chicken Caesar salad, and 2 desserts, ice cream brownie sundae or apple crisp. If you do not make a tree diagram, how could you find the solution? So we have one of 3 appetizers, one of 4 entrees, and one of 2 desserts. So that is a total of 24 options. Neat. That leads us to this special idea, and it's called the fundamental counting principle. For 2 events, if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. So if you have one event in m ways, another in n, then you just multiply them. 3 or more events, the fundamental counting principle can be extended to 3 or more events. For example, if 3 events can occur in m, n, and p ways, then the number of ways that all 3 events can occur is m times n times p. Okay, at a used book sale, you are interested in 5 novels, 3 books of nonfiction, and 7 comic books. If you buy one of each kind, how many different choices do you have? So 5 novels, 3 books, 3 nonfiction books, 7 comics. So that's 15 times 7, it's 105 choices. All right, next one. The digits 0, 1, 2, 3, and 4 are used to generate 4-digit customer codes. How many different codes are possible if digits A can be repeated, B cannot be repeated? So the first thing you need to do is figure out how many options there are. Here, there are not 4 numbers. There are a total of 5 numbers, 0, 1, 2, 3, and 4. So you have 5 options. And you want to create a 4-digit code. So in part A, the digits can be repeated. So the first digit, you have 5 options. You can have either 0, 1, 2, 3, and 4. Second one, you can have second digit, 5 options. Third, 5 options. Fourth, 5 options. So first digit, second digit, third, and fourth. Multiply and you get 625 codes. And these 4 numbers represent the 4-digit code. For B, what if the digits cannot be repeated? Well, the first digit, okay, so we have 4-digit code. Okay, I'm going to multiply, we know that. First digit, you have 5 numbers to choose from. The second one, say you were randomly, or you got 4, then you only have 4 numbers to pick from. Now you only have 3, and finally 2. So this one gave you 5 options to choose from. Here you only had 4 options because one of the numbers was chosen, and so on. So that will give you 120 codes. Now moving on to the next page. An ordering of n objects is a permutation of the objects. List the permutations of the letters A, B, and C. There we go. So if we were to list the letters of the permutations, order them, we can have the letters A, B, C, A, C, B, B, C, A, B, A, C, C, A, B, C, B, A. Those are all the ones that are actually possible. So that's 6 permutations. How could we arrive at the number 6 without having to generate a list of the possible orders? So here's what we can do. So there are a total of 3 letters. Because A, B, and C, that's 3 letters. You have 3 choices for the first letter. Then you only have 2 choices for the second letter. And lastly, 1 choice for a third letter. So that's 3 times 2 times 1. Matt Lauer has 8 news stories to present on the Today Show. How many different ways can the stories be presented? So 8 stories. So you have 1, 2, 3, 4, 5, 6, 7, 8. So all 8 stories right there. Okay. Only 7 left to present. Times 6, times 5, times 4, times 3, times 2, times 1. Multiply all those together in a calculator and you get 40,320 ways. Please don't add them. That leads us, number 3 leads us to what is called factorial. So this little funky thing right here is not n exclamation point. It's read n factorial and is equivalent to n times n minus 1 factorial. Okay, so this should be like this right here. Times n minus 2 factorial, so on. The number of permutations of n objects is n factorial. So an example, how I would write number 3 is 8 factorial means that is, start with the number 8, 1 less, but you're multiplying, 1 less, all the way to 1. So you're counting down, basically. And there is one thing to note here, and by definition, 0 factorial is actually equal to 1. Okay. So that is something of note to write. I'm not going to go into proving why it is, but just note that. Okay, part B. If the news has to be shortened because the football game ran into overtime and only 3 of the stories can be presented, how many possible ways can a lead story, a second story, and a closing story be presented? So this is the proper way to notate this. So, yep, P stands for permutation. There's 8 possible stories, but you're going to select 3. 8, choose 3. So the way you would write that is 8 times 7 times 6. And here's why. You have here in the first spot, lead story, second story, closing story. So 336 ways. The answer in part B is called a permutation of 8 objects taken 3 at a time and is denoted by 8 with that P, then 3. We can write a special formula to evaluate this expression. And here is the special formula. So you have N, then P, then R. And so N represents the number of objects. R represents how many at a time. And the formula is it's equal to N factorial divided by N minus R in parentheses, because you have to do the N minus R first, then factorial. And so we will do this, we will do an example here. So the one that we just did, how would we write it using the formula? So we are doing problem 3b. In the numerator would be 8, it'd be the n, so 8 factorial divided by the bottom two numbers, so 8 minus 3, parentheses, then factorial. Remember what I said. To write out 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Bottom would be this right here is 5. And to write 5 factorial, it'd be 5 times 4 times 3 times 2 times 1. And at this point, you should probably ask yourself, I don't want to multiply all that out, but you don't have to. Here's the beautiful part. Starting with 5s, things cancel. So all you're doing is multiplying 8 times 7 times 6, which is what we did on number 3b. So the answer is 8 times 7 times 6, which is 336. Okay. How many different ways can 4 raffle tickets be selected from 50 tickets if each ticket wins a different prize? So we have a total of 50, but we're going to pick 4. So 50, choose 4. So that's equal to 50 factorial divided by 50 minus 4 factorial. So 50 factorial. And listen, this is what I would recommend doing first. Right here. 46. Why? Because you're not going to write 50 count down all the way to 1. You don't want to do that. You want to start with the smaller number. So what you do is you start with 46 and go 46. Well, actually start with the top one, 50, but count down only all the way to 46. So 50 times 49 times 48 times 47 times 46. Why? Because in the denominator, if you we're starting at 46, is 46 times 45 times 44 times everything after 46 is going to cancel because there's going to be more numbers here and there's going to be more numbers here. But notice everything including the 46 is going to cancel. So you're only left to multiply 50 times 49 times 48 times 47. So this is all you're left with because everything else cancels. Plug those numbers into the calculator and you get 5,527,200 ways. Do you see why the lottery is hard to win? So there you go. Okay, now let's try a couple more. So You have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. In how many orders can you complete 4 of the assignments? So you have a total of 6 homework assignments. You can only do 4 due to time. So that would be 6 factorial divided by 6 minus 4 factorial. So numerator 6 times 5 times 4 times 3 times 2 times 1. And honestly, you could write it if the numbers are small enough. Totally. Bottom, this is 2. So 2 factorials is 2 times 1. So this cancels. That cancels. And you're left with 6 times 5 times 4 times 3. And a lot of students, they write out the numbers just to make sure that they're entering them in right in a calculator. So that would be 360 orders. 360 ways. Okay. How many different ways can a chairperson and an assistant be selected for a research project if there are 7 scientists for the new positions? So there are a total of 7 scientists, and you want a chairperson and an assistant. So 7, choose 2. So that'd be 7 factorial over 7 minus 2 factorial. That's 5 factorial. So you want to count down only to 5. So 7 times 6 times 5 times blah, 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 blah. Bottom will be 5 times 4 times blah, blah, blah. Who cares? So anything after anything including the 5s cancel. So you're left with 7 times 6, which is 42. Right. The last little bit is called permutations with repetition. Consider the letters S, O, S, but notice I have the first S in bold print. If you consider bold S and S to be distinct, that means different, completely different, then there are 6 permutations because you would treat all 3 letters differently, just like you did just with A, B, and C. And those are the possible ways you can arrange them. But if the 2 occurrences of S are considered to be interchangeable, then there are only 3 distinguishable permutations. I'll show you why. Okay. You can have O, S, 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 O, S, and S, S, O. Okay. If you are to consider them interchangeable, right? How could we arrive at this answer without having to generate all of the permutations like we did above? So we could do this. So the question was, you have 3 different letters, and here's how you would do this particular problem. So that would be 3 factorial. And then here in the denominator, you're actually doing this. So 2 factorial, and here's why. And we'll come to a formula. The letter S repeats 2 times. So here we would have 3 times 2 times 1. And down in the denominator, we have 2 times 1. So those cancel. And we're left with the answer 3, which we knew. And so we'll generate a formula, and then we'll do 2 remaining examples. So with permutations with repetition, the number of distinguishable permutations of n objects where one object is repeated S1 times, or this many times, another is repeated maybe this many times, and so on. So repeated once, twice, whatever, will give us the following formula. So P, this is n, equals n factorial divided by S1 factorial times S2 factorial times S3 and so on. So all the way up to N, because that's the number of letters here. All right, so let's do some examples so that you know how to do distinguishable permutations. So look for that. So find the number of distinguishable permutations of the letters in the word soccer. So look at the word soccer. C is the letter that we're concerned with. So that repeats 2 times. Okay, so in order to do this, there are here 6 letters. So we would have, so based on our formula, that would be 6 factorial divided by 2 factorial, because the number of repetition goes down there. The number of letters goes in the numerator. So that would be 6 times 5 times 4 times 3 times 2 times 1, right? And here it'd be 2 times 1. Okay, and so your answers, your numbers left to multiply are 6 times 5 times 4 times 3, which is 360 distinguishable permutations. Okay, and for the word swimming, many letters there. 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters. And so let's see which letters repeat. I 2 times. And the other one I see, obviously, is M 2 times. So how would we do that one? Not hard. So number of letters goes in the numerator, total number of letters. Denominator, the first letter that repeats is I. It repeats 2 times. And the second one is M 2 times. What if there was a third one? You would put it however many times if it repeated 3 times. Like if we did the word Mississippi, that'd be crazy, right? So here's how we would write all that out. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And the other 2, and then this is all multiplied together. The other 2 factorial is 2 times 1. So we can cancel out. And so we're left with 8 times 7 times 6 times 5 times 4 times 3 divided by 2. So we are left with 8 times 7 times 6 times 5 times 4 times 3 divided by 2. And then you could also do some, say, hey, 8 divided by 2 is 4, or just multiply it all out. And you are going to get 10,080. 10,080 distinguishable permutations. And those are your notes for today. Have a great day, Algebra 2 students.